My name is Li Zhang, and today I would like to share with you my work on intent detection using WikiHow. I am a PhD student from the University of Pennsylvania, and this work was done with my collaborators Qing Lu and my advisor Chris Callison-Birch. So what is intent detection? Intent detection is one of the first natural language understanding steps that a task-oriented dialogue system needs to perform before it's able to have a meaningful conversation with the user. Intent detection formally matches an utterance to an intent. You can see an example on the right-hand side. If a user asks what is the cheapest business flight from one place to another, the system first needs to figure out that the user is concerned about checking flight price instead of other possible things like making a flight reservation or modify a reservation. Only after the system understands this, the system can give an appropriate response. For example, telling the user what the price is for a certain business class flight. In research settings, intent detection is formalized as a sentence classification task. In some cases, there are lexical overlaps you can utilize. And in the example on the bottom here, you can see that the word theater has a very close connotation to a screening event. So you might imagine that intent detection is not a very difficult task. However, things are not always so easy in real life. In fact, intent detection can get quite difficult. For example, some intents require word knowledge to infer. Imagine you live in a big city right now. You are just about to go out to eat with a bunch of friends, and you ask your household system, I'm going out, should I wear a mask? It is not immediately clear if you should wear a mask or not, or what even is a mask. But considering the current situation and some common sense knowledge, an intelligent system should infer that your intent is to prevent coronavirus by asking about a mask. And the system should respond according to local regulation, yes you should, or no you shouldn't, or some answers like that. In the previous scenario, the word knowledge can be categorized as common sense. However, sometimes expertise might be involved. For example, imagine a user making a phone call to a musical instrument store to place some orders and is welcomed by a dialogue agent. The user then says, I'd like to buy a tuner. At this moment, it will be ideal if the agent can figure out that the user's intent is to play guitar, because most likely tuner is a tool used on guitars. If this is the case, then the agent can follow up on, do you also want to buy some picks or a pack of strings? If you're a guitar player like me, then most likely you will not be able to resist buying more picks and strings, and then the agent will be successful in persuading the user to buy more commodities, thus showing productive value in sales. What if the user doesn't speak English at all? What if the user speaks a very low resource language? As we all know, for low resource languages, natural language understanding is usually pretty difficult due to the lack of training data. How should a model or dialogue agent handle this kind of situation? It is very difficult to solve the three problems mentioned before using modeling. However, it is possible to use prior knowledge from some kind of learning resource. Now the question is, does a suitable learning resource as such exist? The answer, fortunately, is yes. I would like to guide your attention to an interesting website called WikiHow, which is a website containing more than 110,000 professionally edited how-to articles in English, but also in 17 other languages with fewer documents. Our prior work, published in EMNLP, released the WikiHow corpus as a multifunctional learning resource for NLP. We use the WikiHow corpus for intent detection at the moment. In each WikiHow article, we define a goal as the title without how-to. This goal can approximate an intent. A WikiHow article also includes a bunch of steps, which we define as the headers of each step paragraph, and we use this to approximate an utterance. You can see an example on the right-hand side. If you have a WikiHow article named How to Drive with some steps, for example, learn the driving rules, get your permit, practice driving, you can imagine an utterance would be practice driving or I want to practice driving, and the corresponding intent would be drive. or drive a car. You might notice that this is not a perfect correspondence. Namely, there might be some mismatch. For example, some goals are too specific that they are unlikely. Also, some steps are unlikely utterances. However, the approximation still stands, so this learning resource is still very potent as pre-training data for intent detection. To use this corpus to help intent detection, we formulate a pre-training task as a 4 choose 1 multiple choice questions. Let's look at an example directly. The model is given a step. For example, let check-in agent and flight attendants know if it's a special occasion, and some candidate goals. For example, get upgraded to business class, change a flight reservation, and so on. The aim of the model is to choose the correct goal that correspond to the step. Namely, choose the correct intent correspond to the given utterance. To choose actually relevant and incorrect negative candidates, we utilize the related article sections from WikiHow. Given a correct goal, for example, get upgraded to business class, we look at the related articles of this WikiHow article, and then we take the titles, namely the goals, from those articles. In this way, we kind of have a guarantee that our negative examples will be interesting and most likely actually incorrect. Using this strategy, we construct our pre-training dataset in 3 languages, English, Spanish, and Thai, with varying amount of training examples because there are varying amount of documents in WikiHow in the corresponding languages. Now that we have proposed the pre-training dataset, we also need to find some datasets to evaluate on. For this purpose, we gather 3 popular intent detection benchmarks. I'm going to very briefly go over them, but if you're interested, you are welcome to check out their paper and data. We have SNPs, which is one of the most popular intent detection benchmarks. It includes 7 intents. All of them are pretty commonplace and ordinary, but it does span some of the most essential dialogue functions that a system should have. We also have the schema-guided dialogue dataset, which was just published last year. This dataset is interesting in that it is multi-turn, meaning that a user can have continuous engagement with a dialogue system. The intents are also pretty interesting, spanning a large amount of domains. For example, you can have buying movie tickets, booking reservation with the therapist or hairstylist, or finding tourist attractions when you're visiting a city. We also have the Facebook multilingual datasets existing in English, Spanish, and Thai. This dataset, to our knowledge, is the only multilingual intent detection dataset. Whereas it includes 12 intents, all of them are pretty similar to each other. For example, you have a category about alarms, and you have a category about weather, etc. Next, we introduce the models we used on our pre-training data. We did not do anything too fancy at this stage. We used the pre-trained Roberta model for English and XLM Roberta model for Spanish and Thai. For each of the datasets, we consider several settings. They look daunting, but they are super straightforward, so let me explain it to you. First, we have the in-domain setting, where the model is only trained on the in-domain training data, for example, the data from SNPs from the last slide. Building up upon that, we can also have a setting where you have the model first trained on our WikiHow pre-training data, and then you train it on the in-domain training data. This can be thought as a 2-stage fine-tuning process. We can also do a zero-shot setting where the model is only trained on the WikiHow data and directly evaluated on the downstream dataset. If the target dataset is non-English, there are some more design decisions to make. For example, when we train the model on WikiHow data, do we train it on the WikiHow data in the same language or in English? The rationale of training on English WikiHow is that it has the most articles, and arguably the quality could also be higher. So we further introduce 2 settings, either with in-domain training data or without. In this case, it will be zero-shot, using English WikiHow or the WikiHow data in the corresponding language. The moment has finally come where I'm going to show you the results. This part is where we, the authors, are most excited about, but you, as the audience, might already have guessed the result. Our models perform very well on all of the tasks. In fact, we believe that it achieved state-of-the-art in all of the dataset to the best of our knowledge. Not only that, perhaps a more impressive result is the zero-shot performance on many of the dataset, where the model achieved very high accuracy without looking at any of the in-domain data in the target dataset. At this point, looking at the numbers, you might naturally have some questions. For example, the numbers are very high. Are your results significant? To answer this question, we can answer it in two ways. Statistically, yes, for most of them, because we have done statistical significance test. However, practically, it is more questionable if this is a significant result. I will discuss this further in later discussions. I would also like to show you some results on few-shot transfer learning experiments. To interpret these 6 graphs, the x-axis corresponds to the number of in-domain training examples given to the model, and the y-axis corresponds to accuracy. In each of the graph, the line above corresponds to our model first trained on our WikiHow data, and the line beneath corresponds to the baseline model where it is only trained on in-domain data. It is very intuitive to tell that our model, when first trained on the WikiHow pre-training data, performs very well in low-resource settings. This is perhaps expected because the model has already learned a lot of useful world knowledge that could be essential in intent detection. Finally, I would like to discuss some future work for this line of task. As you might remember, the accuracies we've shown in our table are well over 90%. In some cases, the state-of-the-art is over 99%. Naturally, we can ask the question, are these benchmarks solved? To answer this question, we performed error analysis of our model on the SNPs dataset and the Facebook datasets. We look at all of the examples where our model got wrong. And because the accuracy is too high, there were actually not a lot of them. We conclude that for most of these examples, the model actually did nothing wrong. It was the examples that had errors in them. For example, there are ambiguous wordings or misspellings or overly specific proper nouns. So we can say that it is quite possible that these benchmarks are solved, and future work that want to evaluate their models on these benchmarks should give it more thought, whether or not this would be significant. Perhaps a more interesting question to ask is intent detection solved? If you work in dialogue systems, most likely you'll agree with me that the answer is no. One of the major reasons for that is that the currently involved intents in the benchmarks are in fact very limited. Some of you might ask, well, isn't that because they represent the supported functions of most existing systems? While this might be true, we should keep in mind that there are services like IFTTT, if this then that, or Alexa Skills and some other services that allow users to define new functionalities, which include new utterances and new intents. This creates new domains for intent detection on the fly very rapidly. As a result, we believe that open domain intent detection has a lot of value in this line of work. Our WikiHow data can be used as a preliminary testbed for this kind of open domain intent detection, because if you view every goal as an intent, you will have more than 100,000 intent available in our dataset, although there might be a problem in how tightly they correspond to actual intent. However, we think this is a good start. Finally, we are only using pre-trained transformer models like Roberta or XLM, but we are not considering a lot of the very interesting state-of-the-art models developed specifically for intent detection. If these models can also utilize our pre-training data, we believe that the performance can even be higher, although they might not be able to be reflected on current benchmarks. We have arrived at the end of my talk. Thank you a lot for listening to it. If you are interested, please check out our pre-trained intent detection models and our WikiHow corpus. You can always reach out to us if you have any questions. Thank you and have a nice day.